Good morning. I am Vijay Lakshmi, Professor in Electronics and Instrumentation Engineering Department. Here I am going to discuss about electroencephalogram, a topic under biomedical instrumentation. Recordings of the electric field of the brainwave was made by the German psychiatrist Hans Berger in 1924 and named it as electroencephalogram. Electroencephalogram refers to the EEG record or tracing. The machine used to record is called electroencephalograph and the technique of recording is called electroencephalography. EEG measures spontaneous activity, evoked potential and bioelectric events produced by single neurons. Spontaneous activity, which is measured on the scalp or on the brain. Evoked potentials are those components of the EEG that arise in response to a stimulus, and single neuron behavior can be examined through the use of microelectrodes which spear the cells of interest. Brain waves are naturally occurring electrical signals in the brain which are caused by the neurons firing. These pulses can be measured on the surface of the head using an EEG. EEG is most often used to diagnose epilepsy, sleep disorders, abnormal bleeding, and a first-line method of diagnosis for tumor, stroke and other brain disorders. EEG offers millisecond range temporal resolution when compared to high resolution MRI and CT. At the root of all our thoughts, emotions and behavior is the communication between neurons within our brains. Brain waves are produced by synchronized electrical pulses from masses of neurons communicating with each other. The brain waves are classified based on the frequency range of the EEG signal as delta, theta, alpha, beta and gamma waves. The delta waves have the frequency range of 0.5 to 4 Hz and are detectable in infants and in dreamless sleeps of adults. The theta waves have the frequency range of 4 to 8 Hz and are obtained from children and during reduced consciousness, deep meditation, light sleep and REM sleep. The alpha waves have the frequency spectrum of 8 to 13 Hz and can be measured from the occipital region in an awake person when the eyes are closed. The frequency band of the beta waves is 13 to 30 Hz. They are detectable over the parietal and frontal lobes. Activities like driving, taking an exam and giving a presentation are good examples. Gamma waves are associated with high-level cognitive processing tasks. Each type of brain wave controls a variety of states of consciousness ranging from sleep to active thinking. While all brain waves work simultaneously, one brain wave can be more predominant and active than the others. The dominant brain wave will determine our current state of mind. If we are awake and relaxed, we could be considered to be in the alpha state of mind because our alpha brain waves could be the strongest with the highest amplitude. The internationally standardized 1020 system is usually employed to record the spontaneous EEG. In this system, 21 electrodes are located on the surface of the scalp. In this setup, the head is mapped by 4 standard points: the nasion, the inion, the left preauricular point, right preauricular point. Electrode locations are determined by dividing these perimeters into 10% and 20% intervals. 3 other electrodes are placed on each side equidistant from the neighboring points. EEG electrodes transform ionic currents from cerebral tissue into electrical currents used in EEG preamplifiers. Electrodes used are surface electrode and needle electrodes. The electrodes or leads used in an EEG machine can be divided into 2 types, including surface and needle electrodes. In general, needle electrodes provide greater signal clarity because they are injected directly into the body. This eliminates signal muffling caused by the skin. For surface electrodes, there are disposable models such as the tab, ring and bar electrodes. There are also reusable disc and finger electrodes. The electrodes may also be combined into an electrode cap that is placed directly on the head. Electrodes arrangement may be unipolar or bipolar. In bipolar, adjacent pair of electrodes are used to pick up the signal. In monopolar, between one electrode and a distinct reference electrode usually attached to one or both earlobes are used, or between one electrode and a reference formed by averaging all the other electrodes by connecting them through resistors. EEG signal voltage amplitudes ranges from about 1 to 100 microvolt at low frequencies at the cranial surface. At the surface of the cerebrum, signals may be 10 times stronger. Also, brainstem signals measured at the cranial surface are no longer than 0.25 microvolts. Weak EEG signals require input preamplifiers that have high gain and internal or external noise rejection. System of the EEG machine include data collection, storage and display. The components of these systems include electrodes, connecting wires, amplifiers, a computer control module and a display device. EEG recording setup includes the patient cable consisting of 21 electrodes and it is connected to a 8-channel selector. Every channel of the channel selector consists of an individual multi-stage AC coupled differential adjustable gain amplifier. These amplifiers must have high gain and low noise characteristics since the EEG potentials are in microvolts range. The common mode rejection ratio of the EEG amplifier should be high to minimize stray interference signals. They should have high input impedance and low output impedance. The amplifier must be free from drift so as to prevent the slow movement of recording. The EEG signal frequency ranges between large values, so it becomes necessary to use some of filters including low pass, high pass and band pass filters. The amplified EEG signals are passed through these filter bank. Typical cutoff frequencies for the filters are 5 Hz, 3, 1.6, 0.53 and 0.16 Hz. And the filters are tuned for, band pass filters are tuned for 60 Hz. The high pass filters have typical cutoff frequencies 15, 30, 70 and 300 Hz. The output voltage from the amplifier may either be applied directly to the 8-channel display through the filter bank, or it may be stored as data on a tape recorder or computer memory for further processing. There are other facilities available to record evoke potentials from the brain due to external stimuli like visual stimulus, audio stimulus and tactile stimulus. The time delay between the stimulus and the response can also be measured in the signal processing unit. Thank you.